So we have seen in the earlier topics that electrophilic substitution occurs on benzene. Now let us assume already one electrophile got attached. What happens next when the next electrophile is trying to attack? So for that we have to understand something called as activating groups and deactivating groups. Suppose you have aniline, that is NH2 group attached to benzene. Now if a next electrophile is trying to attach on the same benzene ring, will this NH2 group help or will it hinder? That is the question. If it is helping in making the next electrophilic attack easier, then it is called activating group. If it is not helping, then it is deactivating group. Let us also understand the meaning of activating and deactivating. If an electrophile has to attack the benzene ring, electrophile is looking for what charge? It is looking for electron cloud, more electron density. So if the NH2 group gives electrons, it activates the benzene ring for electrophilic attack. If it is not giving electrons, instead if it is pulling the electrons back out of the benzene ring, then it is deactivating for the electrophilic attack. That is the meaning of activating and deactivating. Let us see what NH2 is doing. Suppose NH2 is present, you have to learn mesomeric effect before this. See the earlier part on electronic effects. So there is lone pair. This lone pair gives electrons like this, so it forms a double bond. Since nitrogen is giving electrons, it gets a positive charge. So no longer this carbon can hold 4 bonds. Now it becomes a 5th bond. So this bond shifts here and a negative charge is produced. So now if you look deeply, what charge is produced on the benzene ring? Don't bother about what is here. On the benzene ring, an extra negative charge is produced. That means this is what the electrophile is waiting for. So it is activating the benzene ring for electrophilic attack. So activating means giving or pumping more electrons into the benzene ring by whatever form. It can be mesomeric, it can be any other effect. Suppose if I take an alkyl group, let us take a CH3 group, C2H5 group, etc. Alkyl groups are plus I groups. Plus I groups give electrons by inductive effect. That is, they give through the sigma bond. This is through pi bond, this is through sigma bond. So they also increase the electron density on the benzene ring. Compared to a normal benzene, alkyl benzene will have high electron density. So electrophile will prefer to attack this than benzene. So example, if I take benzene and if I take toluene. So this is an alkyl benzene. An electrophile, if it has to choose, it will choose this one because the methyl group increases the electron density. That means these groups are activating the benzene ring for a better electrophilic attack. On the contrary, if we have deactivating groups, let us take NO2 group. In NO2 there is no lone pair of nitrogen because that is given as a coordinate covalent bond to oxygen. So what else is possible? Resonance is possible in the opposite way, out of the benzene ring. This bond shifts here. This bond shifts here. As a consequence, this bond is shifting here. So this oxygen is getting negative charge. Once this bond is shifting here, this oxygen is getting negative charge. So I am representing as a negative charge for oxygen. So that is the bond here. So since electron is lost from this carbon atom or out of the benzene ring, on the benzene ring what charge is produced? Positive charge is produced. If positive charge is produced, electrophile itself is positive and already positive. So electrophile won't prefer to attack here. So the chance of the electrophilic attack has further reduced. So if you compare normal benzene with nitrobenzene, if you are comparing normal benzene with nitrobenzene, electrophile will prefer to attack normal benzene but not nitrobenzene because electron density is less here because they are going out into the nitro group, whereas electron density is as it is here. So since electrophilic attack is reduced because of nitro group or electron density is reduced in the benzene ring because of the nitro group, it is called as a deactivating groups. So all groups that are attached to benzene are either activating groups or deactivating groups. This is deactivating through mesomeric effect, that is minus M effect. Here suppose if I take CF3, it is also deactivating, but fluorine being electronegative, it helps in pulling the electrons out, but this is through inductive effect or minus I effect. So these are also deactivating but by inductive. This is activating by inductive. This is activating by mesomeric. This is deactivating by minus M, negative mesomeric effect. So this is about activating and deactivating groups.